I welcome all of you to my channel. In this video, I am going to discuss a relative velocity problem given in 2000 A-level past paper. So this question is regarding a river problem, regarding a river. So the question is, water in a straight river of breadth D. So when we draw the sketch, it is a river like this, breadth is D, flows with uniform velocity U. That means velocity of water relative to earth with respect to earth is U in this direction according to my diagram. A man capable of swimming at a speed v relative to water. Velocity of man with respect to water in any direction. That means we don't know the direction of the man still, but the velocity is v. Swims so that he moves right across the river, perpendicular to the bank. That means if we start from somewhere here, his intention is to reach this location, perpendicular. Since the water is flowing in this direction, the swimmer must swim in this direction. Then due to river currents, water currents, his path will become perpendicular. So we have to first label our letters. M is for man, W is for water, E is for earth. Now we can find velocity of man with respect to earth, relative to earth, is equivalent to man relative to water plus velocity of water relative to earth. Velocity of man relative to earth is perpendicular. Finally, this person must reach a perpendicular location in the opposite bank. So the direction is vertical. But we don't know the velocity. I will label that as W1. Velocity of man with respect to water, unknown. Velocity, magnitude is V. Velocity of water relative to earth is U to right hand side. Then I can give vectors for these. I will write this as PQ1. This is PR plus this is RQ1. For these questions, that means for river problems, we have to use a circle to complete our velocity triangle. So the theory is, first we have to draw a vector where we know both direction and magnitude. First one, we don't know the direction, so we have to interchange these two vectors in this manner because we know both direction and magnitude of the second vector. Now let's start to draw the velocity triangle. First I am going to draw this vector. That is the only vector I know both direction and magnitude. So this is to right hand side U. This is the starting point, this is the finishing point of the vector. Finishing point of that vector becomes the center of our circle which I am going to construct. So this is the center. I am going to draw the circle around that center. Since we don't know the direction of the second vector, I can't draw the second vector. But I know the direction of my resultant. So resultant is from this starting point and it is vertically moving vertically upwards. So I can construct that it is moving vertically upwards to this circumference point. So this is the resultant, which is W1. So the letters are PR, this is Q1. Now I can draw the second vector from R to Q1. So this is the direction of the swimmer. It is theta inclined to the horizontal. Here also theta inclined to the horizontal. So what is the magnitude of W1, velocity of the swimmer? According to Pythagoras, this vector is V, RQ1 is V. From Pythagoras, we can take W1 as V square minus U square square root. Then the direction cos theta becomes U over V, adjacent side divided by hypotenuse. Then theta is cos inverse U over V. So this is the direction of the swimmer. This is the velocity. The question is asking the time capital T taken by the man to cross the river. For that I have to use speed equals distance divided by time equation. So I have to subject T, it is given as capital T from the question. Time is distance moved divided by velocity. I know the velocity W1, it is vertical. So the vertical distance moved is the breadth of the river, that is D. So D over W1 speed, it is V square minus U square square root. So this is the answer for the first part of that question. Now I am going to move to the second part of that question. It states, show that the time he takes to swim a distance D parallel to the bank upstream and back to the starting place is given from this statement. So this is the circle we have drawn to the first part. So we have to change that according to this story. Now the swimmer is swimming a distance D parallel to the bank. So from our sketch, so the swimmer starting from this location now going to swim D distance parallel to the bank upstream. So his motion relative to earth becomes horizontal to left hand side. So PQ, it becomes PQ2, that is the second case. So this is RQ2. So the resultant is PQ2. So we can complete our new velocity triangle in the same circle. This is Q2 point. PR, RQ2, so that is V. So distance from here to here is V. So this is the resultant, which I can label as W2, that is equivalent to this entire line represent V velocity. Then from here to here is U. So the small part becomes V minus U. Now after traveling a D distance, he is going to swim back to the starting point. So that is D distance backwards, that means horizontally right hand side. So this is the first vector R. Next resultant will be PQ3. So this is my Q3 location. According to the direction they have given in the question, we have to complete the resultant from P point, because P is the starting point. Initially it states swimmer is traveling D distance upstream. So we have to complete our resultant vector in this direction until we meet circumference. Secondly is swimming back, that means swimming downstream this direction from P to Q3. Q3 is the point where this line meets circumference again. So this is W3 vector. This should be 3. W3 vector is from here to here U, once again from center to circumference, which is the radius of this circle is V. This part becomes U plus V. Now from this circle we can continue our second part. So I am going to take the time for this motion first, which will be T1. T1 is distance divided by speed. Distance is d distance given in the question. Speed is W2, which is V minus U. T2 is same distance downstream, velocity is W3. Then the total distance is T2 plus T3, which is d over W2 plus d over W3. When I take d out, my common denominator becomes W2 W3. Numerators are W2 plus W3. W2 is V minus U. W3 is U plus V. U get cancelled. Numerator becomes 2V. W2 is V minus U. W3 is V plus U. So this is difference of two squares. Answer becomes U square minus V square minus U square. Now what we have to show is 2Vt over the square root expression. So here we have capital T, but in our answer we don't have capital T. But can you remember, from the first part we have this expression capital T is d over the square root. So when we take d out, that means if I subject d, I have t into square root v square minus u square. So in this expression we don't have, in this answer we don't have d. So now I am going to substitute d. From the earlier part I have subject d, which is equivalent to capital T square root v square minus u square. When I simplify these two expressions, I get the answer as 2Vt over v square minus u square square root. So this is the total time. So what is the simplification? It is like root 2 divided by 2, because I have the same expression. Here I have a square root, here don't have a square root. So square root 2 divided by 2 is 1 over root 2, because I can write 2 as root 2 into root 2, then root 2 get cancelled. We are left with 1 over root 2. So similarly I can simplify these two expressions. So this is the answer given in the question. So that concludes 2000 question number 1 part B under relative velocity. Thank you.